let OA be the vector A and AB be the vector B, as in the diagram. We're given OC is parallel to AB, like this, and that the size of OC is 3 times the size of AB. M is the midpoint of BC, which is there. N is the point on the bottom line that's the ratio 2 to 1. And finally, AB, when extended to the point X, is such that B is in the middle. B is the midpoint. And our goal here is to prove that MNX is a straight line. So just to add all those points to the diagram, I'm going to start with N. So N is the ratio of 2 to 1 here. Next, I'll extend the line to X. And as we know, it's going to be a midpoint at B, so the ratio is going to be 1 to 1. If we know that OC is 3 times the length of AB, then it means that OC is just 3B. And finally, if we know that B is 1 to 1 ratio, B is in the middle, BX must also be B. So let's consider NM. That's equal to NC, ignore that glitch, plus CM, because we can go from N to C, and then C to M. This will be equal to B plus a half CB. CB is the whole line, and M is in the middle, so we're going to do half of it. And we can split that into CO, OA, and AB, like going around all the way around. We can then put these values in. We're going backwards, so it's minus 3B. And then after a bit of expanding and simplifying, we get 1/2 A as our final fully simplified answer. Next, consider NX. So that's going to be going from N to O, and then O to A, and then A to X. Again, in the diagram, you can see we're kind of going around. And remember, it's minus 2B because it's backwards. And then that simplifies down to A. Let's now conclude. We've got 2 facts that we need to state. The first is that the vectors are a multiple of each other and therefore parallel. The second is that there is a common point to both of those lines, and that tells us it must be a straight line.